Welcome my friends and my viewers. In previous two videos, I have covered the symmetry between short-term cost and revenue functions, cost function, as well as the production function, and I have just compared between those two concepts in a very elaborated way. Today's class, I am going to give solve a few MSQs related to this cost as well as the production. So just I am going to solve few questions, numerical questions that is most often asked in your exam, GATE, NET, SLATE and all these exams. So I am going to solve few sums just which are concerned with the cost and as well as the production. So let us start from the first question. First question gives that given Q, production function is 20 under root KL, K is fixed at 100, wage rate is given as 20 and price of the commodity, that is PQ, is given as 2. Now it has been asked that find the optimal use of labor. Now for finding this, or just for solving this, here is the Q, that is 20 under root K. K is given as 10. So 10 goes inside the square root. So this becomes 20 under root 100 L. 100 is again taken outside. So 20 into 10, 200 under root L. Now MPL, marginal product of labor, is delta Q by delta L, the derivative of Q with respect to L, and 20 root L is it is differentiated as 200 remains 200 and root L is 1 by 2 root L, so it becomes 100 upon root L. Now we calculate MRP, marginal revenue product, which is PQ, price of the commodity, into MPL, marginal product of the factor. PQ is given as 2, so 2 into 100 by root L, this becomes 200 by root L. Now the rule says for optimum use of labor, marginal revenue product of the factor must equate the wage rate. Wage rate is given as 20, and just now we have got MRPL, which is 20 by 200 by root L. So 200 by root L is 20, root L becomes 10, so L becomes 100. So 100 would be the answer. Yes, 100 would be the answer. So the optimum use of labor would be 100. This is what had been asked. Now come on, question 2. Given short-term production function Q, 10L minus 0.5 Ls square, this is given, and these two figures are also given. PQ, that is price of the commodity, 10, and the wage rate is given as 20. Now it has been asked, firstly, find marginal revenue product of labor. Marginal revenue product of labor. For finding marginal revenue product, we have to calculate first total revenue product. Total revenue product, that is P into Q. So P is already given as number 2. PQ is given as 10. So 10 and into this is Q. This happens to be the production function. So it is 100L minus 5L square. Once differentiated, it will give MRP. So marginal revenue product is delta TR by delta L. This has been differentiated. So 100L differentiation, it becomes 100, and minus 5L square, this becomes 10L. So this is the marginal revenue product of the function. So this is marginal revenue product. B is the answer. Second question is find marginal factor cost. Now for finding marginal factor cost, we have to calculate total factor cost, and this total factor cost is W into Q, wage rate into Q. That happens to be the production function. So wage rate is given as 20. Here it is given 20. So 20 into Q. This is Q. This becomes 200L minus 10L square. Now marginal factor cost. Once differentiated this, so delta TFC by delta L. So it becomes 200 minus 20L. This is the marginal factor cost. So this is the marginal factor cost. Thirdly, just in connection of this question has been asked, find the optimal amount of labor for maximum profit. It had been asked that find the optimal amount of labor for maximum profit, and for rule says that for maximum profit we have to equate MRP with MFC, marginal revenue product must equal marginal, this is marginal factor cost. Both of these has been calculated earlier. So MRP is 100 minus 10L and marginal factor cost is 200 minus 20L. So when this is solved, L becomes 10. So just to maximize profit, the amount of labor to be used must be 10. So the answer is 10. So this is how these two questions have been solved. Now the question number 3. 3 says that we have the production function 6L square minus 2L cube. Now given this production function, we have to calculate the amount of the variable factor. So in a moment it could be calculated. 3, production function is 6L square minus 0.2L cube. 0.2L cube, amount of labor that maximizes production. Yes, so this Q has to be maximized. So to maximize production, the condition says that delta Q by delta L must be 0. That is 12L is 12L minus 0.6 L square 0. Now 6 could be taken outside, 6L rather. So it is 2L minus 0.2 minus 0.1L. This has to be left over. So it is 2 minus 0.1L is 0, or 0.1L is 2. Hence L is 2 by 0.1, and that is 20. So this will be the answer. So 20 number of labor would be used or would be required to just maximize production. So this would be the answer. Now second has been asked that find the number of labor that maximizes average product. So for this, firstly we have to calculate average product of labor, and average product of labor is Q by L, and Q is already given. Q is 0.6 L square, 6L square minus 0.2 L cube divided by L, that is 6L minus 0.2 L square. This is the average product of labor. Just maximize this APL. Delta or DAPL by DL must be 0. So 6 minus 0.4L 0, 0.4L 6, hence L is 15. So L would be amount of labor would be required, 15 amount of labor would be required to maximize this APL. Now range of labor that a rational producer shall employ. For this a little bit you have to see the diagram. Average product is maximum at 15, and the marginal product was the total product was maximum at 20. So any rational producer shall use the amount of labor which will be in the range of 15 to 20. So right, lowest 15 and maximum 20. So this is the range of labor that will be employed by the producer. So this is 15 and 15 to 20. That has been the answer. This is the answer. So this range of labor would be used by the producer. 15 is required to just maximize average product, and this 20 is required to just maximize Q, or rather TP, total product. So range of labor required would be 15 to 20. So the answer would be 15 to 20. Fourth says if Q, given production function, Q is minus L cube by 3 plus 2L square plus 12L. Now, what I do now, optimum use of labor is, right? for optimum use of labor, Q is maximized. Now to maximize Q, dQ by dl 0. Differentiation with respect to L, so minus 3L square by 3 plus 4L plus 20, 0. Now we have minus L square plus 4L plus 12, 0. Better multiply with minus. So L square minus 4L plus 12, 0 plus 0, and here we have to find the value of L, so this function needs to be factorized. So L square minus 6L plus 2L plus 12, 0. Here L is taken common, L minus 6. That would be minus. That's why some problem is. And plus 2 is taken outside, L minus 6, 0. So we have the factor L plus 2 into L minus 6 equal to 0. So we have the value of L as minus 2 and plus 6. Negative value is meaningless in economics. So definitely L is 6. This 6 number of labor would be used to maximize, or would be required to maximize the total product. This 6 labor is used rather. MP and TP. So this is how this total product is being maximized, and just to maximize this total product Q, 6 number of labor would be required for the maximization of total product. So this is all the 4 sums I have solved. Just I am going to solve some few more sums, and that 2 I am going to solve. Those are virtually theoretical sums related to law of variable proportions, which I explained in the last class. So this must be, those questions are related to that, those diagram, and just I am going to solve. And those are very interesting questions based on the diagram of variable proportions. Assuming L as variable, find true and false. A. When MPL is highest, MC is lowest. Number B, when APL is highest, average cost is lowest. C, when MPL is greater than APL, AC is falling. D, when MC is smaller than average cost, APL is decreasing. And E, MPL and AC are inversely related. Now these all 5 options could be answered through the diagram I had given in the last class. All this could be answered with this diagram. First is when MPL is highest. When MPL is highest, MC is lowest. So this is true. When APL is highest, this point, AC is lowest. Absolutely, this is true. When MPL is greater than APL,